Great to see you here again. As I promised in the previous video, now we're going to look deeper into the assignment problem. We'll look into the creation of the equations that we need to resolve the linear programming problem, and we will use Solver in Excel to resolve this problem. Now, first of all, we have a look at the basic conditions again. I just want to repeat what I said before. You can review the previous session, but the assignment problem is typically about assigning resources to tasks or projects. And like I said before, resources can be machines, can be tools, can be machines, and for example, airplanes or tools that you use or a drilling machine. But they can also be resources like the pilot flying the airplane or the crew that is assigned to a special airplane for a typical flight. Now, we also know that a resource can only be assigned once to a task or a project, which also means that we have a binary problem. So we also have an indication either 0 or 1. That's what's not the case in the transportation problem, but in the assignment problem, it is like this. We only can assign one resource to one activity once. Now, the cost of the assignments also has to be known because we have to calculate what is the cost. And the problem that we finally end up is, in fact, a linear programming minimization problem. But let's now look into the setup of the formulas. And we start with the data that we have. We have a matrix with the cost. So C, I, J are the different costs combined machine and task or activity. So the resources linked to a specific activity or task have a specific cost, which I call C, I, and J. And then we find the matrix. What we want to do is that we want to allocate the resources to the different tasks. And I call these values X, I, and J. So we have in the cost, we have C11, C12, C13 for row 1. For row 2, we have the cost to 1, to 2, cost to 3, and so on. And we also find the same, the variables X, I, and J for the allocations of the resources to the different activities. Now, based on this, or what we said before, we have to know that Xij is 1 when the resource has been allocated to the task, and it is equal to 0 when there is no allocation. So basically, when I look at the columns and the rows, the sum of them can never exceed 1. What are the formulas? Well, let's have a look at the formulas here when I look at the total of the resources, and I just simplify the expressions here a little bit. So when I look at the row, the sum of those allocations has to be smaller than or equal to 1. And for the total tasks, it has to be equal to 1. And basically, we can write the different formulas here. We have for the rows, we can say that the sum X, I, and J for a specific row has to be smaller or equal than 1. We can do the same for the columns, but here we have to have the equality, and we will say that the sum of those elements of the columns is equal to 1. We have to add some more information, some more constraints, because X, I, and J has to be larger or equal than 0, and they cannot be larger than 1. So basically, they are between 0 and 1. Since they are integers, they're either 0 and they are 1. But this is basically the non-negativity conditions that we always have to include in linear programming problems. And then we have the objective function where we have to minimize the cost. So basically, every entry in the table has to be multiplied with the relevant cost and has to be added, and that cost has to be minimum. Now, when we do an exercise, it will be a lot easier to see how we deal with this. And let's look first at all the formulas that we have here. We have the constraints that we have for the rows and for the columns. We have the non-negativity condition, and on the bottom we have the objective function. And these are the elements that we have to find back in our solution when we are resolving this, for example, with Solver in Excel. Let's have a look at the assignment problem with an example. Here we have the matrix with the different allocations, basically with the costs here. And we see that for row 1 we have a cost of 11, 12, and 6. We have for row 2 a cost of 8, 12, and 11. And for row 3, 9, 12, and 17. And we know that the sum of the rows, the resources allocated to the different activities per row has to be smaller than or equal to 1, and for the columns the total has to be equal to 1. Now let's have a look what those formulas are. So for the rows we can say for the first row x11 plus x12 plus x13 has to be smaller than or equal to 1, and we do that for all the rows. So the last one is x31 plus x32 plus x33 smaller than or equal to 1. The next thing that we do is we do the same for the columns. So for the first column I can say x11 plus x21 plus x31 is equal to 1. We do the same for the column 2 and for the column 3. Basically we do that for all the rows and all the columns that we have in our problem. Now when we look at the non-negativity condition, we have to say that those x, I, and j values, that they are positive, larger or equal than 0. Now in the assignment problem we also know that they are in fact either 0 or 1. They're between 0 and 1. Since they are integers, it's either 0 or 1. When we look at the objective function, so we have to multiply the cost with the assignments. So we find 11 times x11 plus 12 times x12 plus 6 times x13 plus 8 times x21 plus 12 times x22 plus 11 times x23 plus 9 times x31 plus 12 times x32 plus 7 times x33, and this has to be a minimum. Now let's see what we can do in Excel. When we put this in Excel, we have to make a spreadsheet. We have to put all the elements in the spreadsheet. So the first table I make are in fact the costs for the different assignments. So that table that we have with the cost, we replicate here. The next element that we do, we have to find, or we have to put there the matrix with the allocation. So the light gray area is in fact the area where Excel will try to put different values to find a minimum. We also look at the total of the rows. We find that in column E from E10 till E12, there we find the sum of the cells B to D, so the sum of the rows, which we have to verify with the supply. We call it a supply, so these are the resources that we have, and we have to see that those numbers are smaller than or equal to the values in F10 up to F12. We also make the total of the columns. So we have B10 till B12 is written in B13, and we do that for all the columns. And the total workers, the total assignments we can make per column is only 1. So we have to see that the values from B13 till D13 they have to be equal to the values in B14 to D14, which is equal to 1. The total cost, we have to make the sum product with the assignments and the costs, which is in fact written down in the cell B16. We've done that before, the way we do the formulas. Anyway, you can try it and you can find the formulas very quickly. But let's have a look at what's happening here now. So basically, when we open the solver parameters, we have to link the numbers to that table that we have made. Now, the first thing we do is set the objective. So the cell B16 is the objective, and we have to be sure that we minimize it. We have to select minimum, and we have to say it is a simplex linear programming problem. So the computer will, or solver will, consider this as a linear programming minimization problem. The next thing to do is to indicate which cells will change when the computer is doing the calculation, which are the cells that will be changed. And in our case, this is the area from B10 till D12. The next thing to do is to enter the constraints. And the constraints, first of all, we have to say that the values in E10 up to E12 are smaller than or equal than the values in F10 up to F12. That's the first condition. You also see that the unconstrained variables are non-negative, so we have to see basically all the variables have to be positive. The non-negativity condition, we should never forget it here. Then we look at the second part, where we have to say that the sum of the columns from B10 till B12, they have to be equal to those different values here, and then you get the right results of the constraints. So basically, once we fill out the constraints here, we have in fact the results, or we have all the basic conditions that we entered into the system. So basically what we have to do now is to just click on solve, and the system will go through some iterations. You can stop the program so you can see all the iterations, and you can select more details related to the solver solution. And basically what you find at the end is the table that we have here. We would have found the same thing with the Hungarian algorithm, which is basically what we have here. So we find that the cost is 26. Machine B is allocated to task 1, machine A to task 3, and machine C to task 2. And basically, this is in fact what I wanted to show to you in this video. We saw the typical way how we can deal with an allocation or an assignment problem. We only have 0 or 1, so we can only assign or allocate a resource to one task or one project. In the next video, we will look further into a different linear programming problem, a different problem that can also be solved as a linear programming problem, which is the transshipment problem. You're doing a great job. I'm looking forward to seeing you in the next video. Thank you, and bye-bye.